Good evening, guys. Just wanted to check what was the last topic that was dealt. Can someone tell me what was the last topic that was dealt in the previous class? So I believe it is differentiation something, right? Guys, can someone respond?
Yes, sir.
What was dealt in the previous class?
The differentiation.
So differentiation, is it over or like is it pending?
Sir used to give sums. So
Okay, so NCERT part is done. So if you can tell me only, I can proceed. Whether I need to proceed with permutations, combinations, or derivatives should be continued.
Sir, I don't think so. We solved
So I need
all the
to know.
problems in NCERT. Only a few selective problems.
Okay, so I have solutions for it that I can give, but as a concept wise, is it clear? Is there any doubt from the conceptual part? But the concepts explained is what my concern is all about.
Yes, sir.
yes, sir.
Concepts are done, right? So concepts are known and you know all the formula, right? The product rule, the quotient rule and everything, you guys are clear. So can I take it as a confirmation? Can I take it as an S?
Yes, sir.
Okay, that's good. So then can I start permutations, combinations today?
Yes, sir.
Yes, sir.
Right, we'll discuss it. I'm assuming this chapter would have been over in your school. Correct?
Yes, sir.
Okay. So anyway, we'll discuss the concepts just a minute. Let's start. So term 2 have derivatives and this permutation and combination. You have the fundamental principle of counting, permutation, combination, and formula for NPR and NCR and simple applications. Okay, then I think only the first two exercises are there. So did they teach completely in your school or how did it work? Did you do word-based problems also?
Yes, sir. We did.
Yes,
You
sir.
did
We
it,
did
right?
all the problems.
We did all the problems. Okay, then we'll go in the order itself. Just a minute. Right. So listen. So can someone tell me what is this chapter all about? What do you mean by permutations and combinations?
Sir, it's all about arrangements.
Yeah, permutation mainly related to arrangements and combination has something to do with selection. Okay, so arrangement has an order, selection doesn't have any order. So when you look at a problem, you should be in a position to say whether you need to apply the formula for permutation or you need to apply the formula for combination. That is, you need to apply NPR or NCR, for which we are going to see the basic of everything, which is called as the fundamental principle of counting. So what is this fundamental principle of counting, guys? Anybody? So let's take an example and then try to understand. Let us consider the following problem. Suppose Mohan has 3 pants and 2 shirts. How many different pairs of pant and shirt can he dress up with? Okay, how many pairs of pant and shirt can he dress up with? So, how many ways can he do? So he has 3 pants and 2 shirts. So how many ways can he get dressed up? Means out of those 3 pants, he has a chance of selecting any 3 pants, right? So 3 into, he has 2 shirts. So 3 into, that is going to give you 6. Is that right? Does it make sense by me
Yes, sir.
directly writing it? So how did I get that 3 into 2? The name of the topic says fundamental principle of counting. Counting means according to me it is sum, but I did multiplication here. So how did I get that? So can you give me the logic behind it? So I'm saying 3
So
into
that's
2. That is
because pant one can be like worn with two
So-
pant shirt two like that.
I can write the ordered pairs like this: pant 1, shirt 1, pant 2, shirt 2, pant 3, shirt 3. Right? Can I write something like this? Similarly, pant 2, I'll write it like this: pant 2 S1 and pant 3 S1. Similarly, pant 2 S1, P2 S2, and P2 S3. Like this, if I write how many such ordered pairs am I going to get? I'm going to get 6. Right? So,
Sir, S3 doesn't exist, right?
oh, S3 is not there, 2 shirts only. Okay. And then I'm sorry. Then this P1 S1, P2 S1. Now I'll have the next set. What is it? P3 S1 and P3 S2. Is that right? So this is what we call it as fundamental principle of counting. Basically, finding out the number of ways a particular task can be completed. Right? So now, so this is what the statement says. The fundamental principle of counting, it says, if there is an event that can occur in m different ways, following which another event can occur in n different ways. So they are subsequent events, right? So there is a particular event. So in which one can occur in m different ways, and there is another event which can occur in n different ways. Then the total number of occurrence of both the events put together is given as m into n, where m and n are the number of ways in which those individual events can be completed. Guys, I hope everyone is clear, right? This is very basic. And with the assumption that you would have understood from school, I'm going a little faster. If there is any place you feel I'm faster, please stop me, okay? So let us take an example 1. Let us take this example 1. Find the number of 4-lettered words with or without meaning, which can be formed out of the letters of the word rose. So how many letters are there? So there are 4 letters given to us. Then how many lettered words are expected from us? You need to form 4-lettered words where repetition of the letters is not allowed. Then what can we do? So generally when you write any word, you start from left to right or right to left. Generally, according to dictionary
Left to
order,
right.
you start from left to right. No. So the first blank space, how many possibilities, how many ways can the first blank space be filled?
4.
So if repetition is not allowed, how many ways the second blank space can be filled?
3 ways.
If repetition is not allowed, the third one can be filled in 2 ways, and the last one will have only one option left out. So according to the fundamental principle of counting, how many ways can you complete this? 4 into 3 into 2 into 1, which is equal to 24. But what is this 4 into 3 into 2 into 1 technically called as?
4 factorial.
We call it as 4 factorial. Right. So generally, what does a factorial of a number mean? Factorial of a number means starting with that number, you come in the decreasing order. So you'll multiply that number with the subsequent numbers in the decreasing order, and you'll stop it with 1. Correct? Given 4 flags of different colors, how many different signals can be generated if a signal requires the use of 2 flags, one below the other? So how many flags are given to you? given are 4 flags. So you have 4 objects in your hand, but they want different signals, and each signal should have how many colors? Each signal should have 2 different colors. Correct? One below the other. Though, this is how they are expecting the signal to look like. If that is the case, then in how many ways can you fill the topmost blank space? You can fill it
4.
4 ways. And in how many ways can you fill this?
3.
So what is going to be the answer? You can have 12 such flags according to the fundamental principle of counting. Right. So these digits and all, you need to be careful. How many 2-digit even numbers can be formed from the digits 1, 2, 3, 4, 5 if the digits can be repeated? So how much is the requirement? You need a 2-digit number, so 2 blank spaces. And those numbers should be even numbers. And what are the digits given to us? 1, 2, 3, 4, 5. So if it has to be an even number, how many possibilities are there for the ones place to be filled with?
2 and 4.
So 2 and 4. So there are 2 ways to complete this. Then in how many ways can this be filled with?
5.
5 or 4?
5.
So the digits can be repeated. So 5.
Perfect. So it is 5. So how many numbers are possible? 5 into 2 is going to give you 10. So just for the sake of understanding, what are the 10 numbers that are possible? So 2, 2, 2, 2, 2, 4, 4, 4, 4, 4, starting with 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So these are the 10 numbers that are possible from the given digits, which are even, and the numbers are getting repeated. Suppose if the question was like this, if the digits can't be repeated, then the digits can't be repeated.
8 ways.
So this will be 2, this will be 4, it will be 8 ways. So what are the numbers that we get eliminated? 22 and 44. Right. These are all very simple. So I'll do one more problem and go to the next exercise. Find the number of different signals that can be generated by arranging at least 2 flags in order, one below the other on a vertical staff, if 5 different flags are available. So what is the question trying to say? Find the number of different signals that can be generated. So they told number of different signals that can be generated by arranging at least 2 flags in order on a vertical staff if 5 different flags are available. So what is the meaning of this? So at least 2 means I can have a signal with 2 flags. I can have a signal with 3 flags. I can have a signal with. Guys, did you understand the question? And I can have a signal with 5 flags also. So how can I fill this? The first one can be filled in 5 ways. The second one can be filled in. Can you use a repetition of flag here?
No, sir.
No, sir.
I can't use because flag is a physical material that I have. Right. So 5 into 4. So from the 5 different colors that you have, if you need to form a 2-colored signal, then how many signals are possible? You have 20 signals that are possible. Similarly, if you want to frame a 3 different signal, 5, 4, and 3, how much is this? It's going to be 60. 5, 4, 3, 2. It's going to be 120. 5, 4, 3, 2, 1. How much is this? This is also 120. Now the question is, this is where I need your answer. Now the question that I have in my mind is, should I add these values 20, 60, 120 and 120, or should I multiply them?
Add the value.
Why?
Sir, because it's or, it's not and.
Perfect. So it is basically union, it is not intersection. So union means addition. I can either form, they told at least two. They didn't say there is no mandatory condition. At least two means I can either form the signal, that is my wish, or I can form this, or I can form this. So there are 20 plus 60 plus 120 plus 120. Totally how many possibilities? 240 plus 60 plus this 320 ways. So there are 320 signals that are possible according to the requirement of this question. Correct? Right? So this is a simple thing. Guys, everyone clear? Will you be able to handle it on your own, this exercise? Is there any problem that has troubled you in NCERT when you tried it? No. Okay, I'm moving on to the next exercise, that is permutations. So permutation basically means arrangements of objects in a given order, in the required order. That is what we call it as permutations, right? So for example, in this exercise, did we see permutation? Is this not permutation?
Yes, sir.
Right. So it is permutation, right? Now, for this, let us see the definition of it. A permutation is an arrangement in a definite order of a number of objects taken some or all at a time. So you will have multiple objects in your hand. Using those multiple objects, you might need to arrange them in a particular order. That order can either be in a linear fashion or a circular fashion. Generally, we don't have circular permutations in your syllabus. We'll go with the linear ones. Okay. So permutations when the objects are distinct. Right? What is the permutation when the objects are distinct? So the theorem one states something like this. The number of permutation means, forget the technical name, number of arrangements of n different objects taken r at a time where r is less than or equal to n. Okay, and the objects do not repeat. So what do you have? Availability is how much? N. Requirement is r. So how many blank spaces should you have? 5, 6, 7, 8. Right? It keeps on going like r, right? Are you guys able to understand what I'm trying to say? So listen.
Yes, sir.
Listen to this carefully, okay? 1, 2, 3, 4. This, let's say, this is the rth box. This is the r vacant spaces that you have. R blocks or r spaces. So in the first empty space, how many possibilities of objects can be placed? You have n objects in your hand. You can place any of the n objects here. Correct? In the second one, how many can you place them? If the objects are not to be repeated.
N minus 1.
N minus 1. Here, how many can you place? You will place n minus 2. Like this, if I keep on going, in the rth box, how many objects can I place?
N minus 7.
So we will write it as n minus r, and that is absolutely wrong. This is where the technique comes into picture, because there is an algebra part. So we need to observe the sequence. So first box, how many do I have? Can I say n minus 0 are available? So I will write it as n minus 1 plus 1. Try to understand, okay? This is the 1 minute. Listen, please. Wait, just a minute. My pencil got discharged. Just a minute. Okay. Now, so this is the case for the first box. Second box, it is n minus 1. So can I write this as n minus 2 plus 1? Third box, n minus 2. Can I write this as n minus 3 plus 1? So what is this number I'm trying to involve, this middle number?
R.
That is the value of R. So in the rth box, what will you have? You will not have n minus R. Don't make that mistake. You'll rather have n minus R plus 1. Seriya? Now, I have a question. Then, according to the fundamental principle of counting, POC, according to the fundamental principle of counting, total number of ways to achieve this task is n into n minus 1 into n minus 2 into so on till n minus R plus 1. Correct? Now the next question is, what will be the number or what will be the term after n minus R plus 1?
N minus R.
N minus R. Here it will be n minus R minus 1. Can I write it till 1? But this is an extra part that I'm writing. So I will compensate with that in the denominator. Correct?
Yes, sir.
So if I start something with n and if I end something with 1, decreasing the value by 1, then what is this whole thing put together called as?
N factorial.
N factorial.
It is n factorial divided by, I start something with n minus R, keep decreasing the value by 1, and I land at 1.
N minus R.
This is what is called as NPR. So the number of objects you have in your hand, where you are arranging R objects from those available n objects without repetition. Is that clear, guys? So this is what is a, you would have seen this formula, right? N factorial by n minus R factorial. No doubt in that. But the question is, how did it come? It came from the fundamental principle of counting only. Is that clear?
Yes, sir.
Please make a note of this. If you already know this, well and good. If not, please make a note. But just make it slightly faster. Yeah.
Done, sir.
Done. Yes. So now what we can do is, see, for example, the same problem is there. No, it's not necessary that you have to use fundamental principle of counting only. So you tell me how many ways this can be arranged. You wrote 5 into 4, right? What is the other way of writing 5 into 4? Can I write out of the 5 available flags, I will arrange, means P. How many flags am I arranging here?
2.
2. So 5p2 is nothing but 5 factorial divided by 3 factorial, which is again going to be 5 into 4, which is 20. So you can solve the same problem with a different approach. That is what I'm trying to say. In a similar way, tell me what will happen here. You have 5 different flags. So 5 objects in your hand. Without repetition, you need to arrange, means P. How many objects?
3.
3.
So 5p3 is going to be how much? 5 factorial by 2 factorial. It's 5 into 4 into 3 only. Same fundamental principle of counting. Right? But next time onward, this 5p3 should not scare you. It is the same thing that we are doing in a different way. Clear, guys?
Yes, sir.
Right. So this is when you do without repetition. Okay. So from this, if I talk about factorial notation, right? If I talk about factorial notation, you guys already know. So only thing is, only extra thing you need to know is 0 factorial is 1. Have that in your mind. I'm not getting into the logic and all those things. 0 factorial is 1. 1 factorial is 1. 2 factorial is 2 into 1, 2. 3 factorial is 3 into 2 into 1, which is 6. 4 factorial is 4 into 3 into 2 into 1. Okay. Now the question is, 1 minute. Yeah. Will you guys, are you guys confident solving this? What is 5 factorial, guys? 5 into 4 into 3
120.
into 2 into 1. It is 120. 7 factorial. 120 multiplied with 42. Because 7 into 6 will come. So there's 5040. 7 factorial minus 5 factorial. Can I call it as 2 factorial? Is that right?
No, sir.
No, you should not. Don't do that mistake. 7 factorial is 5040 minus 5 factorial is 120. So we get the answer as 4920. So 7 factorial by 5 factorial, which is 42. 12 factorial by 10 factorial. So 12 factorial by 10 factorial into 2 factorial. So 12 into. So when you're solving these factorials, right, you should start with the highest number, start decreasing. 12 into 11 into. Stop it with the number which is common in the denominator. So stop it with 10 factorial divided by 10 factorial into 2 factorial. 10 factorial you can cancel. 2 factorial is 2. This will go 6. So your answer is 66. Right? So these kind of problems are important. When you have a general value, you need to know how to solve them. Just give me a minute. Let me pull the sheet. So the 7.2, right? Guys, I'm not fast, right? Is everyone able to understand?
Yes, sir.
Good. So how to solve this? N factorial divided by R factorial into N minus R factorial. Okay, suppose this was not given to us. Okay, suppose this was not given to us. N is equal to 5, R is equal to 2. Then how you start solving? So how you need to do is, out of N factorial and N minus R factorial, which one is greater?
N factorial.
So you should always start like this: N into N minus 1 into N minus 2 into so on till N minus R plus 1 into N minus R factorial divided by R factorial into N minus R factorial. This and this are common. So you're able to understand? I'm just giving you an idea to solve, but this problem you can't solve it that simple because the numbers are given here. So when you substitute this, what are you going to get? They're indirectly asking you what is 5 factorial by 2 factorial into 3 factorial. So 5 into 4 into 3 factorial divided by 2 factorial into 3 factorial. Cancel them. This will go 2 times. Answer is 10. But can someone tell me what is this actually? What is N factorial by N minus R factorial into R factorial called as?
Combination.
NCR.
CR.
It is 5CR. It is 5C2 actually. 5C2 is 10. Yes. So 1 divided by 8 factorial plus 1 divided by 9 factorial plus x divided by 10 factorial. So this is a tricky problem. This is a good one. See, how to solve this? Look at the numbers. Out of 8, 9, 10, obviously 10 is bigger. So don't disturb the smaller number. Plus 1 divided by 9 factorial. Try to write it in terms of the smallest number. So you'll write it as 9 into 8 factorial is equal to 1 divided by 10 factorial. Write it in terms of smallest factorial. Now can I cancel this 8 factorial? So 1 plus 1 by 9 is equal to 1 by 90. Sorry, x by 90. Which implies x by 90 is equal to 10 divided by 9. This goes 10 times. So x will be equal to 100. Correct? Right. So other things you guys can do it. Now we need to get concerned about. So I told you the formula of NPR already. Now the question is, how will you solve permutation when all the objects are not distinct? So when all objects are not distinct, what are you supposed to do, guys? Suppose we have the letters of the ways. Suppose we have to find the number of ways of rearranging the letters of the word root. So if you take root, how many objects do you have in your hand? You have 4 objects. So those 4 objects should be arranged among themselves. Correct? So what should happen? Suppose we have to find the number of ways of rearranging the letters. Means 4 letters are there. Those 4 letters should be arranged among themselves. Where in this case, what is happening? There is a repetition of a letter. What is that letter? It is O. So had it been, for example, had the word been rows, and if you need to arrange the words rows among themselves, then how can you do it? How many ways can you do it? You can do it in 4 factorial ways. Whereas if you have to arrange something where repetition is there, then you need to do it. You can still do it in 4 factorial, where 4 is the number of objects available, divided with what? The number of letters that are repeated, the factorial of the number of times, the factorial of the number that is repeated. So 4 factorial divided by 2 factorial. But why are we doing this? If I do 4 factorial, for example, then what will be the output? I'll get 24 new words. Correct? So if I rearrange the word rows among themselves, I'll get 24 new words, whether they have meaning or not. That is not my concern. But when I do the same thing with root, I'm not saying I'm going to get 24 outputs. Out of those 24 outputs, only 12 are meaningful, is what we are trying to say by dividing it with the 2 factorial. But why are we doing it? Because you take O and O, whether you put the first O first or second O first, the word is still going to be the same. They are identical objects. Means if you write R01, O2 and T and R02, O1 and T, you're still writing the same word root. Correct? So when you're trying to do this kind of a thing, you will only get 12 outputs because the same letter is getting repeated. See, for example, if I have to rearrange the words institute. Okay. In this case, in INSTITUTE, in this, let me underline. I is getting repeated twice. T is getting repeated thrice. That's it. So how many letters you have in your hand? So 9 letters. Remember, 9 letters can be arranged among themselves in 9 ways, 9p9 ways. What is 9p9? 9 factorial by 9 minus 9 factorial. So it is 9 factorial divided by 0 factorial, but 0 factorial being 1, it is 9 factorial. So whether you say 9 factorial or 9p9, they both mean the same. Right? So out of the 9 factorial base, how many things are getting repeated? I is getting repeated twice. So it will be 2 factorial into T is getting repeated thrice. So you need to divide it with 3 factorial. So how to solve this? 9 into 8 into 7 into 6 into 5 into 4 divided by 2. So it will cancel it 2 times. So 10, 60, 60 into 7 is 420, 420 into 72 is going to give you the number of words that can be formed. Guys, am I clear? So I'm hoping all these things you already know. Right. So theorem number 3 is the number of permutations of n objects where p objects are of the same kind and the rest are all different. So n factorial divided by p factorial. So that is what we did till now. Theorem number 4. The number of permutations of n objects where p1 objects are of the same kind, p2 of the second kind, pk are of the kth kind, and the rest. Then you will have n factorial divided by p1 factorial plus into p2 factorial into so on till pk factorial. Right. So find the number of permutations of the letter. Find the number of permutations of the letters of the word Allahabad. So Allahabad, how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 objects in your hand, out of which how many are getting repeated?
A4 times.
1 A4. 1, 2, 3, 4. A is 4 times. L is twice. Anything else? So that's it, right? So 9 factorial divided by 4 factorial into 2 factorial. Generally, I don't know how your school expects. If you leave like this also, you should get marks. But if they ask you to simplify it, you have no other option, you have to do it. That is subjected to the teacher. Okay. Next. How many 4-digit numbers can be formed by using the letters of the digit, by using the digits 1 to 9? If the repetition of digits is not allowed. So you have 9 objects in your hand, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 objects. out of which you need to form a 4-digit number. So it is 94. So you can form 3024 numbers. Now this is a good question. Let's see. How many numbers lying between 100 and 1000 can be formed with the digit 0, 1, 2, 3, 4, 5 if the repetition of the digits is not allowed? So you need to form numbers between 100 and 1000. So 100 and 1000 should not be included. Right? So all the numbers are going to be 3 digits. Right? If the repetition of the digits is not allowed. So tell me how to solve this, guys.
Sir, 5 into 5 into 4.
5 into?
So in the first place, 0 cannot come. So only 5 objects are there. And
1, 2, 3, 4, 5. That's right. 0 cannot come. So it is 5. 1 minute, sorry. 5 objects can come. So here 5 numbers can come. Sorry, here it will be
5 can come.
5 can come, and here it will be
4, sir.
So what is the answer? You can have 100 such numbers. You can go with the fundamental principle of counting itself. It's not complicated stuff. So you have 100 numbers. Find the value of n such that np5 is equal to 42 times np3. So np5 is n factorial by n minus 5 factorial is equal to 42 into n factorial by n minus 3 factorial. N factorial is gone. So n minus 3 factorial is equal to 4 times n minus 5 factorial. So which one is big, n minus 3 or n minus 5?
N minus 3.
So you can write n minus 3 into n minus 4 into n minus 5 factorial is equal to 4 into n minus 5 factorial. Cancel it. So n square minus 7n plus 12 is equal to 4. So n square minus 7n plus 8 is equal to 0. So n minus 8 into n plus 1 is equal to 0. N will be equal to 8 or minus 1. Minus 1 is ruled out. Answer will be. Did I make any mistake? So n should be 8, no? But how they got 10? Did I make any mistake, guys?
Sir, you wrote 4, so it should be 42.
Where?
Sir, on the right
Oh,
hand side.
42. Yeah. Sorry,
Yes,
42, no? Minus 30 then. So 30 means I can take 3 and 10. So n minus 10 into n plus 3 is equal to 0. So n will be 10 or minus 3. So this is the answer. 10 is the answer. So np4 divided by n minus 1 p4 is equal to 5 by 3. I think you guys can solve this, right? I'm leaving it to you. So this one also I already gave you the logic. It's all better. Now this is a good one again. Find the number of different 8-lettered arrangements that can be made from the letters of the word daughters so that all vowels occur together. So this is one kind of a problem where this occurring together comes into picture. So D, A, U, G, H, T, E, R. The vowels are what? A, U, E. So how many consonants are there? D, G, H, T, R. Right. So whenever they say this kind of a thing, how will you solve this? Can someone tell me the hint of how to solve these kind of problems?
Consider the 3 vowels as one.
So you consider the 3 vowels as one object. So that one object, wherever it moves between these consonants, will move as a single entity. Correct? Now, if I consider this vowels as one object, how many blank spaces will I have? I will still have 1, 2, 3, 4, 5, 6, 7, 8. But now, if I consider this whole thing as one entity, then 1, 2, 3, 4, 5 plus 1. I have 6 objects in my hand, where the 6 objects can be arranged among themselves in how many ways?
6 factorial.
6 factorial ways. And means into. Among the vowels, they can be arranged in
3
3
factorial.
factorial.
Right. So this is the answer for the first one. So 6 factorial into 3 factorial will give us 4320. Now next one is all vowels do not occur together. So what I can do is I can arrange the words of daughter among themselves in how many ways? Words of daughter can be arranged among themselves in 8 factorial ways. Correct? I can arrange them in 8 factorial ways. Minus, what should I remove? I need to remove all those words where the vowels are occurring together. That is 6 factorial into 3 factorial. Now, does that make sense? Yes. So you have 36,000 letters or such words which do not have the vowels occurring together. Right. 15th one. In how many ways can 4 red, 3 yellow, and 2 green discs can be arranged in a row if the discs of the same color are indistinguishable? What is the meaning of this? So how many discs do you have? 4 red, 3 yellow, and 2 green. So 4 red, 3 yellow, and 2 green. This to be arranged in a row. If the discs of the same color
Sir, it's just like root, like O1 and O2 will be the same.
Yeah, but if the discs of the same color are indistinguishable. Okay, they are identical. Indirectly, they are saying they are identical.
Yes, sir.
So how many ways can we do it?
9 factorial upon 4 factorial into 3 factorial.
4. That's it. 9 factorial by 4 factorial into 3. Guys, my pencil is not writing. Just a minute. I need to charge it. So 9 factorial divided by 4 factorial into 3 factorial into 2 factorial. That's the answer. So with this independence problem, I think we can stop this exercise. So you guys are already doing it good, okay? So it is 9 factorial divided by 4 factorial into 3 factorial into 2 factorial. So 16th one. Find the number of arrangements of the letters of the word independence in how many ways, in how many of these arrangements would the word start with P? It's an interesting one, right? So, independence. INDEPENDENCE. Okay. So, they want the letter to start with P. So, if the letters have to, so how many P's are there? There is only one P. So, if they want the word to start with P, how many blank spaces are left out? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in those 11 blank spaces, you can arrange the remaining letters in 11 factorial divided by I is repeating itself how many times? No repetition. N is repeating itself 1, 2, 3. So 3 factorial. D is repeating itself 2 factorial. E is repeating itself 1, 2, 3, 4, 4 factorial. So that will be the answer. 11 factorial divided by 3 factorial, 2 factorial to 4 factorial. So first question is find the number of arrangements of the letters of the word. That is 12 factorial divided by the same 3 factorial into 2 factorial into 4 factorial. So I hope the first one is clear, right? Second one, do all the vowels occur together? So how to solve this? So all the vowels occur together means how many vowels are there? E and I, but E is repeating itself 1, 2, 3, 4 times. And I is having 1 time. So out of the 12 letters that are available, if I remove 5 letters, I have 7 letters in my hand. So 7 consonants plus the combination of one vowel put together as 8. So these 8 letters can be arranged among themselves in 8 factorial divided by how many consonants are repeating? N is repeating So
So
you have
n
3
is
factorial,
thrice and d is twice.
3 factorial into 2 factorial into within these letters. So how much is happening? So in 8 factorial, 3 factorial into 2 factorial. This is the number of ways in which those 8 letters can be arranged. And within these 5 letters that are available, they can be arranged, the vowels among themselves can be arranged in 5 factorial divided by 4 factorial. They can be arranged in 5 ways. Means I will take 5 different positions. That is the meaning. I 4 is, EI 3 is, EE 1 I 2 is, like that. Vowels occur together. So how many ways can you, how many words can be formed which begin with I and end with P? Which begin with I and end with P. So I and P have fixed positions. So how many letters are left in between? 10. So 10 factorial divided by the letters repeating among themselves, repeating. That is 4 factorial into 3 factorial into 2 factorial. Correct? So did I skip anything? Oh, I skipped the third one. Huh? I did the fourth one. I hope the fourth one is clear, right? The words begin with I and end with P. So 10 factorial divided by 4 factorial into 3 factorial into 2 factorial. Third one, the vowels never occur together. So that is first one, the number of words possible minus the number of words where the vowels occur together will give you the answer. Clear, guys?
Yes, sir.
So I hope you will be able to solve this exercise, right? Next is combinations. Combinations we'll have a look at it tomorrow. Okay. So last year I had the solutions for all these things. If possible, I tried to upload. So if you have any doubts in NCERT, you guys can have a look at it. .4 and so you did all the exercises. 7.4. Right, tomorrow we can complete it. Okay. That's it, guys. That's it from my side.
Thank you, sir.
Sir,
Tell me.
can tomorrow alone can max class be the same timing?
I'll let you know. I'll let you.
Yeah, okay, fine, sir.
Yeah.
Thank you, sir.
Yeah.
Thank you, sir.